All right. Well, then for discussion topics, um, there's one here that I want to talk about with Laura regarding this Blue Star Zero block detection PR. It turns out that that's already been committed to Quincy. It's already there, but we turned it off in 17.2.1 and actually saw a performance regression relative to previous versions of Quincy. So we want to talk about that and try to understand what's going on there. But until Laura gets here, maybe we can talk about something else. So one other topic that we've been looking at recently is memory usage in the way that uh, we track dupe ops for the PG log. It turns out that when you have a corrupted dupe entry that looks like it's in the future, we stop trimming. And that allows dupes to accumulate basically until that corrupt entry is eventually trimmed, which could be very, very far in the future. So we've done a lot of testing and done quite a bit of work to try to figure out the right way to fix that. The current idea is to basically detect it, and then when an OSD is rebooted with the fixed version of the code and writes are issued, we then slowly, well, somewhat slowly, trim, I think, 10,000 entries at a time for every write, if I remember right, and then get back into a stable state. There was an earlier version of this PR that tried to trim everything on OSD boot up so that we didn't consume the memory at all on reboot. But I think there were some concerns about the safety of that approach. So this is the one I think we're looking at right now. Neha, do you know, did we have a final version of that PR? Did Radic
Yeah, I'll paste it. Why don't you continue? I'll paste it offline right here.
Okay, sounds good. So I think we're basically fairly convinced that that's the right way to go at this point. I've done some testing on it, and it looked good in my tests. I think there's some more official tests of the downstream releases or other packages that are being tested now. So as far as I know, that looks like it's pretty good, and we're going to move forward with it. Um, Neha, any other thoughts on that topic? Was there anything I missed?
No, I think we are trying to do our due diligence from all sides to validate this. And at this point, what we are doing is also validating it on HDDs, which is something we haven't done upstream. So that's where we stand. If things look good, this will be shipped in the next corresponding. This bug goes as far as Octopus, but Octopus is end of life. We don't want to risk the upgrade approach. We've already shipped we will be shipping the offline tool method in Octopus, but up until Pacific, we'll be shipping this fix.
Cool. All right. So then now I see Laura, you're here. Do you want to give a quick update on what you guys found regarding the Blue Store Zero block detection PR performance improvement, I guess?
Sure. So yeah, in the DFG storage team, we've been studying the differences between 17.2.0 and 17.2.1 in performance. And we saw that 17.2.1 had a performance decrease from 17.2.0, and we were trying to better understand that. And we checked the differences in commits and found that there were two major changes to BlueStore between the two versions. And one we ruled out, but the other was BlueStore zero block detection being disabled by default. And this was a feature added to 17.2.0, and which was on by default. And essentially this feature detects zeroed buffer lists and skips writing them to BlueStore. And the goal with that was so that we could perform some large-scale tests, and mainly in tautology, so we can perform tests with many OSDs without filling the devices. But we found in 1720 that this caused some unwanted effects, side effects, so we disabled it for 1721. So we're not seeing, for instance, side effects with RBD thick provision images being thinned. However, in 1720, it caused a performance boost, maybe in quotations, because there were obviously side effects that came with that. So essentially, Mark was interested in understanding where the performance boost came from and seeing if we can get those numbers back in a safer way in the future. But for now, this makes a lot of sense because comparing the numbers to the last Pacific Point release and 1721, those numbers match. And then the only thing in between is 1720, where the Blue Store zero block detection feature is enabled. And that's where we're getting this quote unquote performance boost. So yeah, that was just kind of discovered this morning. So since I was headed with that PR, I'm working with the DFG storage team to, further understand that and everything. But now we understand where that performance boost in 1720 was coming from. That's the gist.
Were those gains primarily in RGW workloads, or were they RBD workloads as well?
It was in the hybrid. What was it? Hybrid new workload, I believe. I don't know what exactly that workload is, but I can check.
So, Mark, from my understanding, it was with small objects, so it's tiny RGW objects that we're writing. And when we say hybrid, it was a mix of read, write, delete, I believe.
Yeah. Casey, I noticed that when I turned on RocksDB compression, that for RGW tests, we saw a huge reduction in write amplification. I wonder if there's a bunch of fields that are, like if there's a bunch of zeros being written out that aren't being compressed in any way, that this thing kind of just avoided writing.
Okay.
I don't know if that matches with what you guys would expect, but is that hypothesis reasonable to entertain, or does it seem weird?
Would we be talking? We'd be talking about bucket index entries in OMAP,
Potential,
right?
yeah, potentially.
Yeah, I'm not sure exactly what integer fields would be like unused and default to 0. There are a couple strings which can potentially get long, and so I could see some benefit from compressing those.
I'm wondering if there's like any intersection between what the DFG team and Laura saw with this and the thing I was seeing, like this zero block detection.
Mark, were those results that you were talking about, do you have them anywhere, or is this,
Yeah, it's in that
document?
It's in that big draft RocksDB thing, which you may not have access to. Let me get you on that. I'm gonna publish it pretty soon, but I'll give you access to read it now. And if anyone else wants access to it as well, I'm going to try to get it into the blog format probably next week so that we can post it. But if folks are interested, let me know. I can give you access to look it over. I'm happy to get feedback. But yeah, I guess what I'm trying to understand is why the zero block detection seemed to improve performance to the extent that it did.
Yeah, I think understanding that and will help us potentially get those performance numbers back in the future. The main topic of conversation with that in terms of enabling it on clusters, not in just synthetic tautology testing. Adam, I believe, said that there is some BlueStore limitations where we are currently unable to mark the extents as logically that they've been used. So if we're skipping writing a zero buffer list, we can't logically mark that the extent has been used. So that's what we would need to look into doing. And that would make it safer to actually have enabled on clusters. But yeah, there are just some limitations in that right now and what BlueStore is capable of.
What workload was it faster on?
I think we're talking about RGW, fill, and maybe hybrid read-write workloads.
Do they use random buffers or do they use zero buffers?
Unsure.
Because if the zero buffers, this is a real short investigation. That's why it's faster. It means there's something wrong with the test. It doesn't mean that BlueStore was faster.
I think this is CosBench, and I don't know what CosBench actually does.
That would be something to check. Laura, have you looked into that?
No, I haven't checked into that, but so you want to know if the workload is using zero buffer lists.
If the workload is sending zeros, then what you've done is you've optimized for the test.
Mm-hmm.
It won't be reflected in any real workload.
Yeah.
Do you see what I'm getting at?
Yeah.
I would be really surprised if CosBench was writing zeros by default.
Until you've checked, though, that's the natural assumption.
Yeah, I mean, it's a silly mistake for a benchmark utility, but it's also a very common one.
It's an extremely common one. Generating random buffers is expensive computationally.
Yep.
Yeah.
It should be sending a static pattern, at least, but it might not be.
I think
Okay, well, that's something
like our
to...
Rados bench, like it fills it in with non-zeros for like the first several bytes, but I think that actually that might be randomized now. It was zeros at one point.
Yep.
And
It's fine as long as the underlying storage system isn't optimizing for it, but, well, now BlueStore is.
yeah.
Yeah, so that is something to check into, because I think the goal now, since we just kind of made this discovery this morning, the goal now, next action items, is to better understand what's going on under the hood and figure out what the tests are using. But that's certainly a thing to check.
Laura,
And basically, if that turns out to be true, you probably don't care about restoring that performance advantage. It wasn't real. It just makes the tests harder to construct.
Sam, if I understand this PR correctly, though, it's for any buffer list that has zeros in it, right? Not just like data that's being written out to the objects.
I mean, yeah, but it's BlueStore, so it would have to be a large enough extent for BlueStore to notice. Yes, there are other things it could affect, but I'd be surprised.
Okay.
On the other hand, I'm not an expert in BlueStore, so yeah.
Well, yeah.
Like,
Yeah,
I would be shocked if it were possible for this to affect OMAP behavior in any way. because level DB SS table writeouts are not going to contain zeros, no matter how hard you pack zeros into the keys and values. There will be other encodings in the SS tables.
Sure. So probably the two are, the thing that I brought up is unrelated, is probably compression and strings along the lines of what Casey was talking about, and the zeros are more on the data side of this, maybe. I could buy that. So Laura, I think Sam's right. It's probably worth looking at CosBench to see if it's writing out zeros. It'd be unfortunate.
Yeah, agreed.
Ooh. All right. Well, those are the two things I had on the list today. I'll open it up. Anyone have anything that they'd like to bring up this week? Gabby, I know.
Yeah, I have something. So the snap mapper I wrote, which skip RocksDB, doesn't seem to impact Paul Kosner performance testing, which is a mystery to me. So I was wondering if you'd be available to help me construct and run a proper test, or sorry, targeted testing to show, or maybe to find out that it's not, that there the impact on snap trim and on clone creation, any clone object creation. I cannot see how this thing will have zero impact. And so there might be something else hiding the performance issue. But at least I want to see that this code is behaving as it should be.
It is strange. I've been trying to keep up with Paul's emails that he sent out, and it looks like the last thing I saw was that he said that through this constant workload, he just sees the OSDs consuming more and more CPU. Is that right?
Yes, it says the CPU percentage consumption is going up over time. I assume that because they have more and more snaps accumulated, and because the amount of work you do is related to the number of snaps. But
Do you know if you profiled at like regular intervals to see, where the time was being spent
I
in
don't
each
know.
case?
I don't really know how to read these emails. I'm not even sure how he's measuring them, but I would want to see at minimum, like if there's a snap trim running on the OSD, there is no way that my code would consume as much CPU as the previous code, just by skipping RocksDB, unless we make RocksDB operation zero cost.
Yeah, I don't know, Gabby. I think maybe the first thing would be that someone needs to actually create a test that actually, measures this, right? Because we don't have anything right now.
Yeah. So that's why I need your help. If you could set up a meeting with me where we could design a test and try to outline the steps that need to be done and what would be considered improvement or what would prove that there is no improvement.
Yeah, I don't know. I mean, what do you can you with the new code that you've written, do you have anything in mind regarding how you think it would be best to showcase those differences?
So say you have a system with many small objects, because clone activity is per object. So if you have many small objects and then there is a write touching all the objects. So I know it's not very normal flow, but that would be like best case scenario for my code. So let's say the objects are very small, 64K each. And then you have some sequential or random write jumping, doing 64K IOs. So every write would touch an object. Then every write would create clone object, which in my code should be more efficient. Then I want to measure timing and CPU utilization. And if there is no difference, then I need to really understand what I'm doing wrong. I do expect to see a difference. And the other thing is, say you have a system with many objects, and now you run snap trim. Sorry, there's a lot of clone object. You run snap trim. So I would measure CPU utilization, just snap trim, do nothing else. CPU utilization and the time it took to do the trim with my code and with the base code. Again, I expect to see difference. And last, I would also check, in both cases, I would check write amplification. Because I don't write to disk, unlike SnapMapper today, which every object is created on RocksDB, and then it have to create a tombstone. So these things tend to create write amplification, but I wonder how much of that it is. So that just to show that my code is making an impact. Once we have it, then we need to design a real test, because I don't even know how you could measure snap impact, because people don't just touch one object. Maybe you do, you create a volume, you populate it, you create snaps, and then you run the same random IO, random write, with my code and with the base code, but you need to have the same seed. So the number of clone object creation should be the same, and then you measure the impact. So that thing would be more related to what you see in real world.
So it kind of seems to me like, based on what you've just said, that it might be a good idea to write a benchmark that's really specifically tailored to do this, and then maybe some kind of more generic. I know the ODF team at Red Hat has run benchmarks where they're looking at snapshot, the impact of taking snapshots during a background workload, but they were basically DDoSing the OSD with snapshots. So I don't know if that's really what we want, but I mean, it seems like you could write a targeted test that maybe would give you an idea of how your code is impacting things, Gabby. What would you think about something like the G-Test suite, just making something that really specifically targets this behavior?
So I would start simple. I mean, even just do snap trim and just measure these things. But yeah, eventually we need to find what is a real world behavior, because in real world, you don't have every write creating a clone object. Because if you hit the same object multiple times, the first one would create a clone object and the others would just be normal write.
I mean, it sounds to me like you've got a good handle on it. Maybe just try it, see what happens.
Yeah, so I would really like to sit with you and design the test. So it's not going to be something meaningless. It's a tricky thing on Snap, because what's the definition of Snap cost? Do you only test it on object on the right, which interface with Snap creation, or do you measure this how the flow is going when there's Snap on the system?
Mm-hmm.
And I don't know what others are doing. How do they measure? It also depends. I don't know, like if you got 4 megabyte object and you do random write, so each one is 4K, then only 1 out of 1,000 would generate clone object. So the overall impact would be very small.
That is what it sounds like Josh was saying, how it should work. So, verifying that probably would be a good idea.
But in that case, I would expect to see that drone overhead is very small. But I don't know that it doesn't seem to be the case.
Yeah, well, and the fact that it increases, the overhead increases over time. I mean, on one hand, sure, you could expect that in RocksDB things would slow down. Maybe there's some fragmentation involved at the BlueFS layer. There's maybe some explanations for why it would get slower, but understanding that exact behavior would be good. I mean, it seems like Paul's making some kind of slow progress on that now. He's starting to figure things out in the last email I saw. So maybe it's just, it's going to take some time to understand that. But yeah, in terms of like, I don't have any real specific advice on this other than just, try crafting something that you think would, showcase the difference between what you wrote and what's already there. And in the process of doing that, you'll probably figure out what makes sense or doesn't make sense. Certainly profile as you go, right? Like try to analyze why things are degrading over time. I think that will tell us a lot.
Yeah, so I think we need to take it offline because I don't want to have everybody now try to design the test.
Sure. Okay. Sounds good. All right. One other thing I forgot to mention to the group, there's a chance that we may get funding for replacing the Smithy nodes lab. And there's a real tight deadline on this. It sounds like we need to have quotes submitted by tomorrow. I worked with David yesterday, David Galloway, to try to nail down potential configurations that might let us kind of keep either systems or VMs that look a lot like the Smithy nodes. There's the biggest concern, I guess, is power usage in the community lab. There is no available additional power. And that is not like per rack, that's the entire data center. So our hands are a little bit tied in terms of what we can do. But the current kind of iteration of the design of these replacement nodes is very much based on trying to maximize power efficiency. If anyone cares about this or has opinions on it, please let me know ASAP, because we're trying to kind of get this nailed down today so we can submit tomorrow. But we're running out of time very quickly on this, so just let me know if you care. The current iteration of this hardware is basically 1U servers with, I think, 32 core, 64 thread AMD processors, and a bunch of NVMe drives that we'll try to split out into like 8 VMs per node. That looked like it gave us kind of the maximum speed for the lowest power envelope. I doubt that we'll be able to do a straight, one system to one system swap with Smithy, since they will take more power than the Smithy nodes, but maybe we can do somewhere between like half to 3/4 of the same node count with a lot of VMs per node. That's kind of what I'm hoping we'll be able to do. And I don't know if each VM will be quite as fast as Smithy, but I'm hoping it'll be pretty close with a big increase in the count. So anyway, that's kind of the current rough plan on this. Yeah, let me know if you care. That's basically it for that.
From my perspective, I think anything that gives us similar test throughput to Smithy is fine.
Yeah, Sam, that was kind of what I was thinking too. If we could get even close to the current test throughput with Smithy, but then have more nodes available or more VMs available, so that people aren't waiting in queue as long. That would probably be a win. The current jobs, I think, are still spending a fair amount of time waiting on a single compression for logs or other random weird stuff that take a long time on a single thread or single core. So increasing the number of VMs, even if it's at a slight decrease in performance per VM, is probably a big win, I think. So anyway, that's basically it for that, unless anyone else has thoughts or questions on it. All right. Then anyone else have anything they want to discuss this week? All right. Well, then have a great week, everyone, and see you next week.
Mark.
Bye.
Thanks, Mark.